parallel lines and transversals. So a lot of terminology today. Very little math. So we need to establish, just like we did in chapter 1, we need to establish the vocabulary so that we can all talk about the same thing. We're going to set up some scenarios here. We're going to learn some words, and then we're going to use those words later on. All right, we good? Beautiful. Line relationships. Two lines can interact in 3 possible ways. What are they? What can 2 lines do together?
They can intersect.
They can intersect. Okay. They have one point in common. What else?
They can be parallel.
Parallel. I'm a little iffy on that word. Could you clear that up for me?
That means that
First of all, could you spell it?
P-A-R-A-L-L-E-L.
Very, very good.
That means that they'll go on forever without ever intersecting.
In the real world, can you give me an example of some parallel lines?
The door frame, like if one straight up, it would never
Oh, if that door frame extended into infinity. Anybody else? Examples of parallel lines? Doesn't have to be in the room, anywhere in the real world. There's an obvious one. Maybe it's not so obvious. Megan? Railroad tracks, perfect. Just think about what would happen if railroad tracks weren't parallel. Make a mess. Okay, so new symbol also. 2 little slashes next to each other means parallel because we don't want to write out big scary words. Emmett's definition was almost perfect. I did throw in a new word there, coplanar. What does coplanar mean? On the same plane, yes. And I'm pretty sure no one knows the third scenario, but I'll ask anyways. Does anyone know the third scenario? 2 lines across, 2 lines that are parallel. Third case is what's called?
They're the same. I don't know the word for it, but
They're the same. How can you have 2 lines
the
then?
same slope.
They have the same
Y
slope, same
intersect.
slope and same y-intercept.
Yeah,
So you're saying like 2 lines stacked on top of each other?
yeah.
But we're talking about 2 dimensions, so you can't stack things in 2 dimensions. So it would be the same line. Everybody understand that discussion? Right, you know, we can't stack things on top of other things on a piece of paper because it's a flat surface. So that idea of stacking doesn't work. Would be a good solution if you could stack. We're talking 3 dimensions. Michelle, were you gonna say something?
No, I think, well, I was gonna say perpendicular, but I think that's the same as intersect.
Correct. It is. It's a special case of intersecting, which we've talked about already. All right. The third one, again, I wouldn't expect you to know this, but is skew.
Oh, okay.
Who's talking? You heard that before? Wow, that's impressive. Look up here for a second. Skew lines would be like this. Okay. They're non-coplanar, they're not in the same plane, but they never intersect. So if they're squished down onto a flat piece of paper, they have to intersect. If you elevate one above the other, then they're skew lines. Like, for instance, this edge up here and that edge down there, which will make a lot of sense on the video. We are not going to deal with skew lines a lot initially because we're still working in a 2-dimensional world, but when we get to 3 dimensions, we're going to be all over skew. We're going to be dealing with these 2 puppies first, intersecting and parallel. So first new word of the day is parallel. Well, skew also. First 2 words of the day, parallel and skew. How are we doing so far? Hot diggity. All right, so here's a picture. Ben, could you basically describe to us what you see in that picture?
Alright, the parallel lines are EG and KH.
All right, I like that. It's got some parallel. How do you know they're parallel, Ben?
I'm just assuming.
Oh, you know what happens when you assume things?
You touch your butt.
Correct. When you assume things, you touch your butt and then point at both people. Does everybody know what I'm talking about?
Yeah.
Okay, good. Do you know what I'm talking about, Ben?
I've seen you do it here before.
Okay, do you understand?
Oh, I get
Yeah,
it.
you make it.
Oh.
I get it.
Yeah, okay.
I'm
You
sorry,
do-
you spell.
Yeah, you point, this is not a butt. You don't make a butt out of you and me. You make a donkey. You know what I'm saying?
Gotcha.
Okay, go. So you assume that they're parallel.
Yeah.
Okay, is he right in that assumption?
Yeah.
You're all just gonna jump on that bandwagon, aren't you? Sure, Ben's a pretty bright guy. We'll go with it. Hey, notice those two little red things there?
Yeah.
Those are an extra set of arrowheads. That's how we denote parallel. You put an extra set of arrowheads on it. Back to you, Ben. What else you see in this picture?
I think the skew are FJ and KH, just because there's a dotted line. over
Looks
that.
pretty solid there. Good. Yeah. Hey, what's this blue thing?
It's a plane.
Good. And there are 3 lines in that picture.
Yes.
Which lines are in the plane?
All of them.
Nope.
EG and KH.
Good. Which line passes through the plane?
F and FJ.
Good. And what's the fancy term for G? The point where a line passes through a plane?
Intersect.
Yeah, but the fancy name for that particular type of point?
Toe. Sure.
Not toe, not loafer.
Foot.
Foot. It's the foot. Very good. The point where the line intersects a plane is the toe, the foot. Good. So, does everybody agree with Ben that this line KH is skewed to the line FJ?
Yeah.
Good. And we no longer have to assume that EG is parallel to KH because we've got the extra set of arrowheads in there. And then I think we would all see that EG is intersecting FJ. Okay. Solid?
Yes.
Nicely done, Ben. Now we go 3-dimensional. Does anybody happen to have any idea what that thing's called?
Pyramid?
What kind of pyramid, Mr. Smarty Pants?
Oh,
Rebecca?
pentagonal
It is a pentagonal pyramid. Pentagonal, tomato, tomato. Regardless. We don't care about that now because we're still only doing 2-dimensional stuff. But notice, like on the plane, we have some dashed lines back there showing that those things are hidden. That's just dashed because it's on the surface. Okay, so you can see a whole bunch of intersecting lines. Any problems with that? Do we really need to talk about the first question? Can you see which ones intersect?
Yeah.
2 things that you want to consider about that. What lines are intersecting and where is their intersection? So if I say, for instance, the line GC and the line CD, where's their point of intersection? C. Okay. Are we good? All right. Which lines are skew? Think carefully before you answer. Vanessa.
GF and
GF and
CD.
CB.
CD.
CD. Hold on.
Or CD.
Goat, ferret, and cat, dog?
Yes.
Okay. Does everybody agree?
Yeah.
I don't know.
You don't know. Just go. I'm going to abstain on that one. Thank you. GF goes up and down. CD goes that way. Are those 2 lines ever going to meet? It doesn't appear that they would. And there's a whole bunch of other. You could say something like gopher, elephant, and badger, cat. Those 2 would be skew. Which lines are parallel?
None.
None? Why would I ask that question then? Oh, you're on to me. Yes. None of those lines are parallel. How about some planes? How many planes in that picture?
6.
Grace?
6.
6. Good. Which 2 of those are intersecting, Grace? A little practice on naming planes.
AEG and GED.
Elephant, aardvark, goat, and grasshopper, eel, donkey. Solid. Good. And what's the intersection between those 2 planes?
EG.
Elephant, goat. What kind of thing would elephant, goat be? A segment, a line, or a ray?
A line.
Beautiful. We good? Nice. All right. New word, transversal. As it says up there, a transversal is a line that intersects 2 other lines. That's it. We're not putting any more stipulations on the transversal. That's just what it is by definition. And as it says up there, when a transversal crosses two other lines, it creates 8 different angles, which I have labeled up there. You don't have to label them that way, I just did it because it's easy to refer to them. And so this scenario is going to create new pairs of angles. And we've already talked about 5 pairs of angles. And Jack is going to be kind enough to remind us of the 5 pairs of angles we've already talked about from the last chapter.
Obtuse, acute, right, straight.
No, those are types of angles. We're talking pairs. Is that a new shirt, Jack? That's really nice. Is it? Yeah, nice. New shorts too. Did you get your haircut?
No.
It's looking good, man. How about those shoes? No, those shoes you've had for a while. They still look good though, even though you've had them for a while. You're not getting it, are you? I'm not just being creepy. Maybe, yeah, but that wasn't the intention. What am I doing? Good looking shirt you're wearing, Jim. Ball.
You're complimenting.
Yeah, complimenting you. So pairs of angles would be complementary, good. And supplementary. You like sitting next to Molly? Okay, vertical. We're gonna jump ship on that one, but that's okay, vertical. You like sitting next to Molly? Next to Molly? Adjacent, good. And the last one I cannot do it. I don't have anything clever for that. You'll need one more though. Somebody else? Linear pair, good. So those are the 5 that we have already. This is going to give us a whole bunch of new ones. So first pair. First pair. There we go. Corresponding angles. Notice there's 2 points of intersection here. There's a point of intersection up here around where 1, 2, 3, and 4 meet, and there's another point of intersection down here where 5, 6, and 7 meet. The pairs of angles we're going to talk about are, you're going to choose one from one point of intersection and one from the other point of intersection. The first one are called corresponding. They're in the same location. The cows are in the upper left up here. They're in the upper left up here. So therefore they are corresponding. Which question?
Why are there cows?
Because why not?
Because they're.
Hey, why not? You don't like cows?
It just confuses me.
Cows confuse
You know
you?
that there's cows on these angles. Why wouldn't there just be numbers?
Because
Okay,
Whatever, you do your.
there's numbers.
You like
1
it.
and 5.
Okay.
That works for you? You don't like the cow? I can change it if you like.
No,
Wait,
I'm
watch.
changing
Hold
cow.
on. Cows are good?
Yes.
Where are the other corresponding angles?
2 and 6, 3 and 7, and 4 and 8.
2 and 6, 3 and 7, 4 and 8. Okay. Upper left, upper left. Upper right, lower right, lower right, lower left, lower left. 4 pairs of corresponding angles. And notice the abbreviation over here, CORR, and you could even use the angle symbol if you wanted to get all saucy on that one.
Can you go back to the previous slide? for a
Certainly.
second?
You don't like the cows either?
No, I don't like cows.
Okay. At least someone likes cows.
Those cows are great.
Cows rock.
How do you write it from the corresponding?
CORR period, core, and then angles. Good? All right. Next pair. We good with corresponding? Yo. Yeah, we did that already. Next pair. Is this better?
What are they?
Those are, that's a little star holding a cane and tipping a top hat. Alternate interior angles. So, let's break that down by the name. Alternate means they're on opposite sides of the transversal. One's on the left, one's on the right. Interior means they're in between the 2 lines that are intersected. That having been said, Will, where's the other pair of alternate interior angles?
Oh, 7 and 2.
Nope. Those will come later. Those are alternate, but they're not interior.
Oh, 4 and 5.
4 and 5, there we go. Only 2 pairs of AIA. Alternate interior angles. Okay, Will, since you started this mess, you mentioned 7 and 2. What do you think 7 and 2 would be called?
Alternate exterior angles.
Oh, you dog. What do you think I used to represent alternate exterior angles? I'll give you a hint. I didn't use cows or a star. I did not use God.
You said thank God.
Oh, you said thank God. You have no idea.
A moon.
Guess. And this will blow my mind if you actually guess right. It's not a bad guess.
Duck.
Duck is good.
A big letter X at the top.
Batman would be awesome.
Go for it.
Yeah, you don't even want to guess.
Apple.
All right. Extremely creepy unicorns. It's a little hard to see, but what that unicorn is doing is looking off into the to the left there, and then it turns and looks at you like. It's really creepy. Alternate exterior angles. Will already told us about 2 and 7. I use the other pair. Alternate again, opposite sides of the transversal. Exterior on the outside between the 2 lines that are intersected. And angles because they're angles. Okay, what other pairs didn't we talk about? We're good? All right.
Wait, wait.
Oh, I didn't.
Okay.
Oh, hold on, fishies.
Oh my gosh. Sticky.
Fishies.
There.
Big
The next
bug-eyed fishies. Consecutive interior angles.
CIA.
The interwebs. Where do you find everything?
How are you gonna move?
Consecutive, meaning, what's the matter, Megan?
How do you get them to move?
Magic. It's math magic. I did something. I just fell over. Consecutive means on the same side. We used to call these same side interior angles, but then some math guy went and got all fancy and introduced the word consecutive. Consecutive interior angles, CIA. Where's the other pair?
4, 6.
4 and 6. Which other pair haven't we talked about? Megan.
Consecutive exterior.
Beautiful. CEA. Which I just realized I don't have a slide for. Oh. Thank you for the one. Appreciate that. CEA would be consecutive exterior angles. 1 and 7, 2 and 8. Need to rectify that situation promptly. How many pairs is that? Is that 4 or 5? It's 5, right? CIA, CEA, AIA, AEA, and corresponding.
Yeah.
Beautiful.
Where was the last one? 1 and 7 and 2 and 8.
Say again, that's I'm sorry.
1 and 7, 2 and 8.
1 and 7, 2 and 8, correct. Same side of the transversal on the outside of the intersected lines. Okay, let's see if this makes any sense now. So now we get rid of all the numbers, we get rid of the moving objects to distract you, and I've labeled those 8 angles using mouth jaw. Or Wajisu, or Masuo Jawi. Let's go with mouse jaw. Lillian, where are the, what am I looking for first? I think I'm looking for the corresponding angles. What do you got for me? Lillian,
O and J.
say again, I'm sorry?
O and J.
O and J is one pair, that's good, you got 3 more to go.
U and A.
U and A, good, that's 2.
S and W.
Awesome, and the last one?
M and E.
Well done, golf clap please. Where are the AIA? Andrew,
Those would be S and J and U and E.
outstanding, good job, golf clap. How about the alternate exterior angles, Dev?
O and W and M and
Well done, golf clap. And the CIA, Ashley?
Awesome.
And?
U and J.
Well done, golf clap. And I probably neglected to include the CEA. Mary, which ones are the CEAs?
M, W, and O,
Well done, golf clap. Excellent. Okay. Now notice, we've made no statements about the relationships of these angles. We haven't said they're equal, they're complementary, they're supplementary, nothing, just what they are. Okay. Corresponding angles, alternate interior, alternate exterior, consecutive interior, consecutive exterior. We're all done. Okay. Snapple fast fact for today. We good? I don't believe the homework is up on Schoology yet, so as soon as I stop recording, I will put that up, and then we'll be good to go.
Wait, having no need
It's all relative.